Hi guys. So, thing to remember for a nodal, you must know the currents that flow through a resistor. Okay, for example, I select the current directions that is exit from the node. So here is the nodes. So now in nodal, I assume that the current is exit the nodes. Therefore, in order to find the currents for that branch or junctions, you have to know the polarities of the resistor. For example, if I choose this one as a R, so R1, then you must know the equation for the VR and use the Ohm's law to find the currents. For example, the currents that flow through the R1 is IR1. Okay, so I in Ohm's law, IR1 is equal to V at R1 divide with the R1. Okay, so from the VR1, in order to find the VR1 is voltage potentials from the higher to the lower part. Or I assume that I select as a V at positive, B positive minus V negative. Okay, for example, if I choose the current is exit from this node, so the positive value will be at this side and then negative value at this side. So positive at this node. For example, if I choose this one as a V1, here as a V2, therefore VR1 is V at positive, which is V1, minus V at negative, which is V2. And then in order to find the current, you have to divide with R1. If you not divide with R1, it will become voltage. So you have to divide with the R1s. Okay? So this is one of the types of circuit that you will find in the nodal equation. And sometimes if V2 is ground, so when V2 is ground, it means that the V2 is equal to 0. So by reference to these equations, the V2 will be 0. Therefore, the I R1 will become V minus 0 over R1. So it means that VR1 over or divide with R1. Okay. This is a second types of circuit. Another thing is nodal. You must know the currents at that branch. If the current is already have the source, which is current source. Okay. So then you need to find the current at this branch. So this means that, for example, if this one is a 2M, so you need I here. So I is equal minus 2M because the I is in opposite direction. Okay, the objective of nodal is to find V node. Okay, if you found a circuit that look like this one, so here is the V1. So if you found the circuit that look like this one, so no need to to do KCL because your objective is to find V naught. Okay, so if I compare V naught here, so V1 is V1 to the ground. Okay, so here is V1. If I do the KVL here, for example, this one is V source. Okay, when I do the KVL at this loop, KVL minus Vs plus V1 equal to 0. So then you already know the values of V naught, which is Vs. So no need to do the KCL at this node. Okay, you already get the values of the voltage. Okay. Now, if your circuit consists of a dependent source, which is current source or voltage source, so there will be extra equation. There will be extra equation that you need to provide into the nodal equation instead of the KCL at node. Okay. For example, if there is voltage source, for example 2ix. Okay. So there must be allocations of the ix. For example, I choose here ix. So I select this one as a V2, for example. Here is the R2. Okay. What you have to do here is, for example, if you do a KCL at this node, okay, there is a lot of branch here. So I'm just considering the currents at this branch. So the current at this branch, for example, IR2 is equal to, assume that all the current is exit, so this one is exit. So V2 minus 2Ix. Even though it writes, it returns in the Ix, but this one is a voltage. The Ix is only a variable. Okay, this one is only variable. The units is volt. Okay, so V2 minus 2Ix volt over R2. So this is the equation in the KCL. Yeah, there will be a KCL equation which is you add the current here, and currents at this branch. So there will be another or extra equation that we call as a constraint equation, which is constraint equation is what is Ix? The Ix must be in terms of V, because the objective is to find V naught. So as you can see here, this is Ix. So Ix is flow to the flow through the R3. For example, I give this one as R3. So it means that by using the Ohm's law, so Ix is equal to V R3 over R3. So what is VR3? Same thing that you have to do every time you want to do or find the currents, you must know the polarities of the resistor so that you can use the Ohm's law. So the polarity at the positive side is V2, the at negative side is 0. So it means that the VR3 is V2 minus 0 over R3. Okay, so for me, I will not write the 0. So I just choose the V2 over R3. So Ix is V2 over R3. Okay. And then each of the not circuit that consists of the value lah. Okay. So you can see that this is the V0. Yeah. Now you have an extra equation. Hopefully you can understand the functions of the dependent source. So let's see another example. For example, I choose this one as a positive, and then this is a resistor, and then another resistor, another resistor, another one, and then I choose this one as a dependent source, which is I choose this one as a voltage, dependent voltage source to V1. So here is 2 ohm, 3 ohm, 4 ohm, 10 volts to 5 ohm, and then to V1, where is the locations of V1? So V1 I choose as here. Now, first thing that you have to do is how many nodes? 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. 3 nodes. Select one as a ground. So I choose this one as a ground. Now you have two essential node. So it means that there will be two equations. Okay, either KCL or Ohm's law or Ohm's equation. As you can see here, so I select this one as a V1, here is a V2. So first is how many variable? 2 variable. Plus with another one variable, which is the constraint. One variable. So I choose here as a Vx. Better lah. Okay, Vx. So V1, V2, and Vx. So 3 variable. It means that 3 equation. Okay. So first equation is came from the first node. So you can see that there is a branch. 1, 2, 3. 3 branch. 1, 2, and 3. So V1 minus 10 over 2 plus with V1 over 3 plus V1 so minus V2 over 4 equal to 0. Okay. Second will be, you can see that this branch do not consist resistor. So it means that the V2 is equal to Vx. So no need to do the KCL because the V2 is 2Vx. So V2 is equal to Vx. How to know the equation for this one? So V2 is from here to here is V2 by using the KVL. You can see that minus V2 plus 2Vx equal to 0. Then the V2 is equal to Vx. So number 3 is, what is this one? Constraint. So Vx is equal to V at positive minus V at negative. So V1 minus V2. Okay, now you rearrange this equation and then put that into the matrix form. V1, V2, Vx, then you can find the V1, V2, Vx. That's all.